Buddy, my name is Mike, and in this video I want to go over a few things that can significantly influence situations we have with pandemic, especially contamination and cross-contamination. How do those things happen, and how do some ventilation systems contribute to that, and what we can do to change it. And also I'm going to be going about the significance of design of air purifiers that I'm working on. And so right here what I have is a typical scheme that's a scheme of many of hospital and other public facilities, and I have drawn a few different situations here. So actually, if we look, so this room, this one first in the middle, it's the typical room. It's how things are usually or close to what things are usually assembled like. This here is a situation when we have the principle of my air purification built into typical HVAC system. And this here is a typical HVAC system with freestanding air purifiers of the type I'm going to be going about. And for the purpose of this picture, we would see that this is an HVAC unit here that supports, so these are the inlet lines, so they push air, the red line, air goes to the HVAC system, and on the blue lines you can see the air is distributed to the rooms. So now let's go over some details, and I'm gonna try to remove the walls so you can see more of that, and talk about how some things contribute to keeping air clean. So again, I removed the walls, and this is how things look schematically. So again, let's look at the 3D model. And I just want to point out again, I'm not an HVAC specialist. I'm a physician, but I know what things are too, because it was all in the med school about the ventilation systems and how they're supposed to work. So again, let's look at the typical room and what challenges do we face. So in many hospitals, it's actually the layout I've seen in many hospitals, unfortunately, and it hasn't changed till now. And there can be slightly different layouts, but the main goal of this layout, that's here in the center, this one, it's that you have the outlet of the air, the cold air or heated air, conditioned air anyway, comes to the patient compartment, to the patient chamber, and it goes all the way here. So, and here we have the air inlet. So again, it comes actually like this. So if you think about it, everything that is, all the air that is, maybe some like contaminated air here in the patient compartment, in the patient area, if the patient is in fact infected with anything, it's going to actually go all to the, usually there's a nursing post around here, so it's going to go into hallway, and everybody who's going to be in contact with the air is going to be exposed. It doesn't mean he's going to be infected and get the disease, definitely, but he's going to be exposed, so that's not good. Now let's see what they're trying to do. There might be different presentations of this type of system, but usually what you would notice in most of commercial projects, what you can see is that usually the outlet, which we have here, and the inlet into HVAC system are both located, they're both located under the ceiling. Yep. So if you look at it, you would have this situation where actually the air comes out here, and it kind of travels. Well, some of it falls down, but it eventually has to get up again. So anyway, any particles that are in the air, they actually are, while that air is being moved this direction, so all the particles, they're actually gonna keep floating, more or less. it actually prevents the natural way, the natural process when particles are gonna just fall down. So the systems that we have, the HVAC systems, they are actually contributing to keeping infectious rate high. While there's not enough good evidence about it, still it makes sense, and unfortunately there's not much done about it. And I want to point out that the CDC has always been saying that the best way to fight pandemics, much more effective than, let's say, appropriate use of PPE, is engineering solutions. So here we have the first engineering solution, what we can do to this system. So first of all, we wanna place a filter on the HVAC system. So the yellow part is the filter there, and filter goes on the inlet. So actually all of the rest system, it's already filtered, so the air goes clean. And you want to put at least 3 filters. There will be one that's high, like gross particle filters. You would want to apply those on the inlets. They're usually foam-like filters made out of like foamy material that absorbs most huge particles. Then you can also apply here or any other spot of the filtering system. You would want to apply like dust filters. So those are not HEPA filters. Those just filter those would filter gross particles and most of the dust, and they should be easily accessible, like here, so you can frequently change them. And for example, foam filters, you can actually wash them, they're reusable. And the dust filters, you would have to change them, but they're much cheaper than HEPA filters. And if you filter most of the dust, so the HEPA filter, you don't have to buy a big one. Then you can have a lesser unit, and it would be still pretty sufficient to filter most of the stuff, and it wouldn't get clogged up by the dust. So while we got our filters going, what we would want to do, and it's the preferred thing to do, is to add UVC lamps. So UV, ultraviolet light, has been shown for decades now that it's really safe and effective options. But as you might see in many buildings, that they would put something like this on the wall, especially in hospitals. There will be a UVC lamp that shines like mostly up to the ceiling, but it actually is not very effective, because UVC light its effectiveness is determined by opposite square rule. So meaning, if you have a light source, a UVC light source, and you can see that the lights go in different ways, but the further you go from the light, the power of the light drops down dramatically. So here you have a pretty good effectiveness here. So the air that goes by close to the lamp is gonna get disinfected. But as long as you get just a little, you have to square the distance. So that's gonna be our L square, and then divide your power, your effectiveness, by that L square. So if you the baseline is, if you increase distance from the light source just a little, that dramatically decreases the effectiveness of UV light. So what you want to do, you would want to put some lights inside these folks, or somewhere in these pipes. So the air is going to be going close by the UV radiation lamp. That's the goal, and it's gonna get effectively disinfected. So what you can see here in this project here, there's no lamps. So these are lamps here, there's no lamp here. And the goal, the case is, you might came up with the system where you don't actually need too much lamp, or you need less lamps, because you can use bulk of UVC light Actually, UVC light goes through the air mostly unabsorbed. But if you go down here under the ceiling, and if you place a UVC bulb here, and you place a screen that is gonna let the air go out, but it's gonna, so the way that actually fluorescent lamps work, they're all UVC, but they have this special coating on the inside of the lamp that converts UVC, not UVC, just UV light to visual light. So you can actually put special screens with the coating there that are gonna transform the residual UV light to visual light that's not harmful to you, but it would give you the advantage. So you can use actually UV powered sanitizers might actually be used instead of, or kind of substitute for visual light. So that's where you can save some money. Just, you know, you can use them instead of lamps, both to kill the viruses and bacteria and to have a light. So now back to the point, what is dramatically changed in this construction compared to the other one? So you can see that the intake pipes, these red ones, they go all the way down here and down here. Yep. So, and you see that instead of one outlet here, you have 4 smaller outlets here. So what that gives us is, instead of having the fresh air that has been filtered and sanitized go all the way from up till here, we keep it confined in one room. And more than that, what we are getting is that I removed some walls so we can have a better exposure of this system. So what we can see here is that the light is actually the air is actually gonna be going out of these pipes and going, first of all, down. So the air is directed down from each point, and it goes from multiple points instead of one big one. That gives us less difference in the pressure, and that in the end gives us less turbulence. So the turbulence is actually an issue, because if you have even a clean air coming out of here, but if it goes with you know, a great speed, then it actually is gonna take some air from outside, which might be contagious. So if you have contagious air, it will mostly immediately mix with the air that's around. That will of course reduce the amount of particles, but that's not gonna, you know, keep it clean as we want it to do. That's gonna actually, that effect actually reduces the effectiveness. And that's what I want to show here. That, let's say we got a conventional air purifier here, and we put it here, so it kind of sucks the air in and it puts it out like a clean air. So yeah, this air is gonna be clean, but actually it's gonna mix with the air around. So this air goes up and it's gonna mix with the air around and make this turbulent flow that actually contains some of the contagious air. And then there's another problem. So let's say we have a patient line here. Yep. And we have someone a doctor who came in here and wants to do some cool things to the patient. And with the COVID, we don't know who is actually infected. So even if you have a clean air coming from here and to the patient, because it sucks from different directions and it gets distributed in different directions. So again, it's gonna go by the doctor. The clean air is gonna go by the doctor and get to the patient. And if the doctor is infected and asymptomatic, then we get the patient infected, and vice versa. And again, with any system like that, you can get infected. And in fact, the other problem is, even if you would want to place a negative pressure ventilation, let's say this is a pump that pumps all the air out, so the fresh air comes through here from the corridor, and that's good to contain stuff here. Yep, that's gonna keep the stuff in the room. But what is gonna happen if, again, we have a patient that came in with, let's say, a broken leg, and we have a doctor that has been on call for 50 hours, or how usually doctors are, you know the drill, and the doctor has contacted with some COVID patients, or maybe he has a COVID but he's asymptomatic now, and you have a negative pressure ventilation. Still, the air that's being sucked in with the negative pressure ventilation is going to go by the doctor, get infected from here if he is, or anybody else who is in the hallway might be infected, and it's going to go to the patient who might not be infected. So in certain instances, the problem is, in certain instances, things like negative pressure ventilation and air purifiers, conventional air purifiers, can actually not only not help us to fight the problem, they might actually somehow be contributing to spreading the disease. So back to our system, what we have here, we try to achieve the laminar flow, so the air goes slowly in here, and the same goes here, and the same goes there, and the same goes here. So it goes slowly by and doesn't, like, or at least mixes the less. But the problem is, as the air goes down, it keeps all the stuff down. So it actually helps the natural way of the things to keep all the particles down. So even if the air comes in, even if it doesn't give you it's super clean air, or doesn't actually protect you, but it still contributes to natural factors of keeping all the infectious stuff down, instead of because it's then gonna be sucked in here and in here and other, and it keeps it down. And then if you have a patient here that's asymptomatic or symptomatic, nobody cares, nobody knows, and you have a doctor or a nurse that came in here and doing all the cool stuff, so actually the air is always gonna go here in between the patients. So the doctor is gonna get the fresh air, and the patient is gonna get the fresh air from the both sides, because it's gonna go all around. It's gonna go actually all the way like this through the room, keeping all the bad stuff in. And basically, no matter where the specific individuals are located, they are gonna be usually getting fresh air, unless somebody stays right under one of the outlets and sneezes and coughs. But that again means that only the people who are gonna stay right close to him might be infected, and actually the fact that all the air goes down still reduces the possibility of them getting infected. So that's how, just simply modifying, just adding a little, instead of one big outlet, you add more smaller, and the same thing you do with inlets, and you drop them down. This simple modification, it will cost you probably just a few bucks, would actually change things dramatically. Okay, so now let's go to the air purifier. So not always you can do this, not always it's easy to modify the system. Well, usually it is, but even if you don't, if you want to have, this is a mobile option. So again, as we already said in all of our previous examples, that the red spot is the intake, the blue place is the outlet. So this here is just the same thing, and you can actually put it, you can move it wherever you want. This is a column that you can plug into outlet, or you can actually hook it up to the ceiling. It's a light fixture. You can hook it up to the ceiling and get the power from your lamps. And again, because of UVC lamp, you can try to use it instead of lamp. Well, it's still in progress. I'm working on getting that done. But what this thing does, it releases the fresh air from up and all the way around itself. Yep. And then it sucks the contaminated air down from the bottom, from all the sides. So again, it keeps all the nasty stuff, stays down. That's what we want to achieve. Even if we don't sanitize air immediately, at least we contribute to keeping things down. And then, so if you have a two individuals, let's play Simpsons, make them yellow guys. If you have two individuals in the room, 2 or 3 or maybe even more individuals in the room, basically it doesn't matter how are they gonna be located around this thing. They can go, both ways. Still, every given time, every given minute, both individuals are going to be getting fresh air, because it's going to be going from up, and all of the things that they exhale, and they're going to go down. It's going to all stay down. And in this fixture, so what we are talking about again, it's having trying to keep the small particles down. The small particles, they can stay in the air for extended time. I don't know why it was a question in the first place, can it happen, but it actually has been shown that the stuff remains in the air for up to 3 hours. This is one of the problems. And if you have just a conventional system that blows the air in, so the turbulence makes it all mix, and it just stays, it slowly drops, but some fraction of that is gonna stay in the air all the time. But again, by changing the way how we distribute the air, keeping it down, and fresh air coming up, so we're gonna move the layers of the air down, and the small particles are gonna go down. Because for the big particles, if somebody just sneezes and spits, you can use basically a face shield for that, and that's gonna be significant enough to help you contain the system. So you can implement both options, this one or this one, in basically any situation. And even if you have still a turbulent airflow coming here, and it might get infected from the patient, it's gonna be hit by the outflows from here and sucked in here, and then the fresh air is gonna continue to the inlet. So you would still reduce, even if you keep the conventional AC system like it is here, with the air going to the hallway or to the other people, but just adding these rectifying columns, this air purifying columns, and using the same simple air purification, so they just keep it like that. So simple, but it's gonna dramatically change the amount of infectious particles in the air. So thank you very much everybody who stayed with me. I'm gonna in the next video go and explain more about the construction of these things and how am I making them, and I'm gonna show you how simple it is to make one and how cheap it is, so everybody can benefit from those. The hospitals, the schools, you can just deploy those instead of having people to stay home all the time and being afraid to go to hospitals. So please comment, and I want to hear your thoughts, and have a great day everybody.